welcome everyone. One and all, we are super excited that you're joining us and are interested in contributing to Jina AI through GSoC. So I'm Emma Jade, Senior Community Manager here, and I'll be hosting our session for today. So what I wanted to do actually is run you through our agenda. So just quickly, obviously we want to give you a warm welcome to the program that's we're running. Also give you opportunity for our mentors to give a short introduction about themselves. I'll walk you through then all the projects that you can get involved in. And of course, make sure that there's also time for us to kind of answer questions. And so Sami, maybe you can mute. I can hear background noise. So no worries. Yeah, basically just to give an introduction as well about Jina AI itself, and for people that are also new to kind of our projects and what we're working on. So well, we are multimodal AI for the community, for everyone. And so our goal is to empower businesses and developers to create cutting-edge neural search, generative AI, and multimodal services using state-of-the-art LMOps and MLOps and cloud-native technologies. And our team is extremely passionate about this technology. We are iterating at like hyper speeds to stay at the forefront of our domain. Even in the past like 2 weeks, we deployed a couple of really innovative projects, agent chain, microchain. So I think this really, for me personally, shows also like how quick we are to build new projects and to innovate in the space. And just as a side note, you can read all about our tools and projects and prototypes via our blog. So where our technical writing team, together with our engineers, provide a really great kind of go-to source for cutting-edge insights on knowledge, providing you with like high-quality content that I believe is always really ahead of the curve, actually. And so just to give you maybe some quick facts as well about Jina. So we were founded in February 2020, and since then we are an international team of 65 and still growing. And we have 4 offices with a globally distributed team from very diverse backgrounds. And we are super proud to have raised like 38 million in funding and honored to have received recognition from prestigious publications like Forbes, DAC AI 30 in 2020 and CB Insights AI 100 in 2021 and 2022. And just to kind of wrap up a little bit this introduction, and just to like what I really want to do is emphasize like our commitment to open source, which also something for me personally is why I'm also very proud of working for Jina. Jina AI is, of course, it's a major part of our identity at Jina AI, and the values we hold very true is our commitment to kind of open source development and to our community. And so you can definitely find like multiple ways to contribute for our like multiple open source projects. And one highlight for sure is like kind of keeping up with our values, and shows this as well, is our team donated DocArray to Linux Foundation in 2021. And basically, we then established a neutral home to build and support kind of open AI and data community through truly like democratized development. So in truth, we couldn't be more like appreciative of the support from our like talented community, kind of helping us to make our technology what it is today. So like through these initiatives like GSoC, which we will talk about today, we're really excited to kind of just encourage even more collaboration like amongst our diverse community going forward. And really, this is a super like wonderful kind of shared opportunity for all of us to work with our experienced team of mentors to kind of level up your skills and be part of this vision that we have. So yeah, without further ado, I'll let our mentors also introduce a bit about themselves, and we will kind of just dive into the projects and showcase what you can be involved in. So yeah, so maybe we can run through the introduction, guys, from the list. So maybe you want to go first?
So I should start. So hello everyone, my name is John and I am head of engineering at Jina AI, and I am working remotely from Barcelona in Spain. I'm happy to be here and introduce the projects that we have in mind.
Awesome. Is Felix here able to introduce a little bit?
I don't think Felix is here.
Okay, well, we have Felix Lang as well, and Philip, who is our head of developer experience. And yeah, he's been working on multiple projects in the past, leading a lot of teams. He's highly passionate about kind of just open source community in general. You'll definitely find him on social media, sharing a lot of really, really awesome content, and just kind of, like, definitely someone to follow. So really a great mentor to have as well. And maybe Girish, if you can also introduce yourself.
Yes. Hey, so yeah, my name is Girish. I'm joined Jina in last August. Helping Jina with search, cloud native integration, and other things.
Awesome. Thank you, Girish. And maybe Johannes, you have an introduction?
Hi, I'm Johannes. I'm a machine learning engineer here at Jina. I'm mainly working on DocArray and now overseeing this one project for Google Summer of Code, the one that deals with wrapping NN libraries in our document index class. Whoever will work on this project will interact with me, and looking forward to working with you guys.
Nice. And Sami?
And then it's me. So, hey, everybody, I'm Sami, a machine learning engineer working here at Jina AI, working closely with all of the other people who are present themselves, but yeah, mainly working on our two open source projects, or two of our open source projects, Jina and DocArray.
Aladdin?
Okay, then I can go last. Hello, everyone. My name is Aladdin. I'm a software engineer at Jina AI, and I mainly work at the Jina framework. So happy to be part of this collaboration, and looking forward to working with you guys.
Awesome. Great. So maybe we can also then run through some of the projects. So just kind of taking it one by one. And of course, like, if folks can ask some questions, there should be a Q&A function also in webinars. So if you want to ask a question, feel free to just ask them throughout, and we'll try to kind of answer questions on each project kind of as we go along. So maybe we can, I'll just give a quick rundown of kind of all the projects that we have running for our GSoC. So we have, and also just to mention, we will go into more details about the difficulty level and the size as we go through the projects. But first one is building executor model UI in Jina, DocArray wrap-N or ANN libraries, research about deploying LLM with Jina, expand nLite's capabilities with BM25 to build hybrid search, make nLite the go-to vector search library to be scaled by Jina using stateful executor feature, and then JAX support in DocArray version 2. So maybe we can already jump in. So the first couple of projects, so we have first built executor model UI in Jina. So maybe one of our mentors can run through this one.
Yes, so I don't know if you guys have checked Jina software and Jina library. So basically, our executors are like components to build services. So for now, a Jina executor supports gRPC protocol, and one of the most common use cases you can achieve with this executor is model serving. And basically, we aim to add automatic model UI for Jina executors. So the idea is to leverage type hints and type annotations that are put inside the executor implementation in order to generate service description, the same way Open API descriptions are generated for HTTP protocol. And then we aim to automatically, given this service description, generate a user interface that should include multimodal components, like to handle sending and receiving multimodal data for our executors. So maybe to explain this better, maybe we can go to the next slide. Yeah. So to give you a better description on how we would implement this, so the first step is to offer an open API-like service description. So the idea is to leverage the DocArray v2 schema that is present in the Jina executor in order to offer automatic service description, whether it is for HTTP or gRPC protocol. And to give you a better context, DocArray v2 is a rewrite of DocArray, where we favor schemas and type annotations to describe your data. And this means executor input output becomes on one hand more flexible and more representative of your multimodal data, and on the second hand it becomes explicit in terms of schema. So the executor service schema becomes known and can be described this way. So can we go to the next slide? Yeah, so the second step is to use this service description to build the model UI. So the model UI is basically an HTTP server or an HTTP website that offers the input components based on the service input, and also showcases the output components. So I will give you a concrete example. So suppose your executor implements a service called service1, and the input is an image and a string, while the output is a string and another image. So basically, this should be easy to implement using Grad.io framework, for example, where we put an upload image component and a text box component as input, and we show a string, a text component and an output image component. And this way, we end up with a UI that can be served using Jina Gateway. And basically, the Jina Gateway should be able to request the service description from the executor, and this executor will serve back this information, given that we have already implemented the service description as in step 1. And finally, it's all about showing all of these components using Grad.io server within the Jina Gateway. Okay. Does anyone have questions about this?
Yeah, if you guys have questions at all, feel free to drop in the chat. There's Q&A function, but otherwise you can drop it in and we can answer. Otherwise, feel free to just ask maybe throughout the session, and we can also come back to them in case you think of something you want to ask later.
So I think there's a question, how many people for this project? I guess, Emma, it will be one person chosen per project, right?
Yes, ultimately, as maybe Jaz in the chat and you can clarify, but I believe it would be one person chosen by the project. We have quite a few questions coming in, so I'll just get also Jai, if you can just clarify that one. Also asked, can you explain better why Gradio?
Of course, I only mentioned Gradio as an example. Such model UI can be, of course, built with other frameworks like Streamlit or just bare HTTP website. Yeah, I just mentioned Gradio because it sounds convenient given its flexible components, but of course it's not definitive. Like anyone can use any tool or library to build a user interface.
Nice.
Yeah, I think the second question is kind of related.
Exactly. And then Avikans asked, what is the expected outcome of the project? Is it an end-to-end demo?
Yeah, so I would say the expected outcome is features within Jina framework that implements the 2 steps that I described. And optionally, we can also have an end-to-end demo where you enable this feature, this model UI on an example executor, and we see how we have this automatic UI for any, I don't know, your favorite multimodal model like Blip2 or whatever. If a new model comes, we can show how this looks like.
Awesome. And before I step into the next one, we had one come through the Q&A. What are the basic skills necessary to work on this project for a beginner?
I would say web development, some web development skills, because you need to be familiar with HTTP and optionally gRPC as well. And then I would say Python programming is most needed skill.
Awesome. And then
there's another question also.
Yeah. So we could read it out if that's possible.
Yeah. So do we have a model to showcase the Gradio integration, or we expect to put together by ourselves? We can showcase the Gradio integration or the model UI integration using any model of your choice. Preferably, it would be a multimodal AI model like Blip2, for example, because this one receives an image and a string as input and spits out a string as output. And we feel there will be even more models with the same architecture or the same behavior. So we can use, I think they would be perfect to show this feature.
Awesome. Thank you so much, Aladdin. I think that's all the questions so far. So just in respect of the time, we can maybe just continue. And then, yeah, if there's any other questions, either we can try to find some time at end of session, or of course, we invite you to our Slack, which I'll share a link to at the end. So maybe you're also presenting on this one, but regarding the research about deploying LLM with Jina.
Yes, exactly. So I guess everyone heard about large language models recently and their capabilities in terms of language understanding, but also in context learning and so on, even reasoning. And in Jina AI, we want to embrace this new technology and be able to host and serve this large language models at scale. But deploying and serving a large language model by definition relies on a few techniques, like because they don't fit on a single GPU, and therefore you need to do the techniques like model partitioning or optimizer partitioning across different GPUs, or even if you don't have all the GPUs within the same node, then you have to split this model across different nodes or servers. Another technique is weight offloading, where you like where the model weights are like mainly stored on the CPU and sent to the GPU when needed, when computation of the layer output is needed. Another technique is model compression and hardware optimization, and we can cite different libraries to achieve all of these. But mainly, the main idea is we want to achieve a large language model deployment with Jina by incorporating one of these techniques within Jina framework in order to enable serving and inference. So the expected outcome is to demo how to serve a large language model with Jina, and in case this demo requires an integration or a feature within Jina, then we also expect to build this integration. So so the goal here is to enable these technologies in a local setup first, and then as I said, the tech stack or libraries to be used is up to the contributor to choose. but mostly at the end we will end up using one of these techniques. And then we want to assess these technologies within a cloud environment. So Jina, as you all know, is a cloud native framework. So it can be hosted on a Kubernetes cluster or Jina Cloud. So we also want to see how this large language model inference behaves in such a cloud environment. And if it's necessary, we would like to build integration or support for these technologies within Jina framework, and at the end, demo or showcase a project with the introduced technology. So I guess we already have a few questions.
Yeah, so
Yeah,
you
so
asked, oh, sorry, you go ahead. Go ahead.
Yeah, so I spotted this one. I think it's the first about large language model. It says, does LLM include 6 billion, 175 billion? Is the elastic deploying and inferencing feature needed? If I understood well, we cannot bound large language models to a specific scale, right? Of course, it would be great if we support the 6 billion or 175 billion. And in the future, if we have like even bigger, like 500 billion or whatever, the goal is to make it possible to infer a large model at scale by using one of the technologies mentioned, or if a new technology comes up. Yeah, I think we're not bound to a certain size. We just want to enable this scalability because we don't have it or we did not try it out or test it at the moment.
Great. I just want to, so someone asked through the Q&A function. So they said first they were very interested in this project and going through a DeepSpeed library, they saw broad support for DDP and parameter weight sharding. So basically they want to ask, so they feel that DeepSpeed would be a good choice. The title, however, says research. Does this imply that we wouldn't have to implement this?
Yes, so if DeepSpeed turns out to be the great technology, like the most convenient technology to host a large language model, then it is, right? But of course, we need to assess if this is compatible with Jina, if there is an integration needed, because we all know that DeepSpeed requires a launcher script. So we also need to check or assess this hosting of a large language model within Jina, and most probably we will require integration. Yeah.
Okay, and I guess we can just run through the chat. I'm not sure if we asked this one, are these already trained LLM models?
Yeah, I think of course we would like to try with the pre-trained LLM model. We don't want to just come up with a dummy large model and then try to host it or deploy it. But yeah, whether it is pre-trained or fine-tuned, it doesn't really matter because we just care about the scale. We don't care about the quality of the model itself. It's up to the user. Once we have the feature or the integration, it's up to the user to choose whether they want the LLM trained or like more fine-tuned. Yeah,
Will
so
the hardware optimization be done by us or just use Jina framework to do the optimization?
Okay. So I guess this one might depend on the cloud environment and on the underlying hardware. I would say maybe in most cases, Jina framework should not care about the hardware optimization, and we would like to give flexibility to the user in doing these optimizations. But as I said, we would like to assess our compatibility with this technique. So maybe when we try to enable a hardware optimization and infer the Jina like host the model within Jina framework, we find out that this technology is not compatible with our software. Okay, this next question says, can we take a pre-trained existing large language model and not worry about performance of the model? I would say yes, as long as we don't degrade the model. For example, if we explicitly enable quantization so that the scale of the large language model, like the size drops and then it fits in one GPU. Yeah, I think, yeah, we can use pre-trained. Is this project close to RNNs and NLPs? I think maybe not RNN, but I would say transformers in general, because large language models adopt the transformer architecture. And yeah, I would say it's definitely close to NLP. Is the priority of skills required? Yeah, but just to go back to the previous question, the project is more close to the cloud native side and the inference and hosting side of the language model. So we will not be training a model or fine-tuning a model. Yeah, so I will go to the next question. Is priority of skills required more inclined toward NLP or deployment of models on the cloud? I would say deployment of models on the cloud. Yeah, how many people are needed in this project? Yeah, maybe Emma, you have the
Yeah, I think this is one of the FAQs, so it'll be the same. So we'll choose one. We had someone in the Q&A session as well. So what do you think about FlexGen? Would this be a good fit for this project?
So what are the list of optimizations that we are expected to do in the large language model deployment, like caching or any similar approach? Yeah, I already listed some techniques that are most commonly used when you want to infer or host a large language model. And of course, the contributor can suggest a different technique if he would like, and we would like to assess these approaches.
Awesome. Okay, so I think any of the general questions, we can save them and answer throughout, maybe typing if Shah is also in the chat. So also in interest of time, maybe we can move on to next project. And yeah, type some answers if we can, if anyone else can answer some of these answers, some of these questions, rather. So yeah, maybe we can just jump to the next one. So yeah, we have here another couple of projects. So, oops. Oh, I'm clicking on a link. Sorry, guys. So yeah, expand analytic capabilities with BM25 to build a hybrid search.
Hello. So let me explain this one. So one hot topic that still is a hot topic, although most of the hype and attention is brought to LLMs, is the ability to combine the benefits of neural search, let's say vector embedding based search, with the qualities and robustness of traditional BM25 based search for text. And this is what we want to explore, is if we can add this capability to our in-house developed vector search library, ANN Lite. And that's the expected outcome. That's what we want to investigate, if we can do that. So some background. So ANN Lite is a vector search library that is developed by Jina. It's one of our open source projects. It does pure vector approximate nearest neighbor search with the HNSW algorithm under the hood. It has some filtering. It has filtering capacities, as many of the HNSW implementations. The library is written in C++, but is wrapped as a Python library, and this is how it is offered to the community. And then eBread search as an approach has proven to provide great value. when doing text-based search. And it combines the robustness, interpretability, and years of experience of BM25 with the semantic understanding that vectors provide to these search solutions. And the idea is here is to make sure that in this library, we can have the data structures and algorithms in place that host the data so that you can compute both scores, the BM25 score and the vector search score, like the cosine similarities and so on. And also to combine these scores smartly to get the best precision and record. So if this would be kind of the how this would look like. So you would have inside an light wrapped some HNSW based graph structure and some inverted index structure that each of them is responsible to provide different scores and different list of documents based on their own logic. And then there would be someone combining these into this hybrid score that is the source of truth to provide results from these search queries. And yeah, there I think we have a list of what is expected from this project. So it is expected that we integrate this inverted index structure into NLite, that this NLite search API is extended so that an hybrid search is performed. We need to be robust and have unit tests and integration tests for that. And one of the most important things is that we have to evaluate this solution in terms of performance from both the memory requirements, the latency, and so on. And then also we have to have some quality improvement. We want to measure the quality improvements brought by this approach in different benchmarks.
All right. So now is the time to ask questions about this project. So just checking back if we had any in the chat in the meantime. But please do throw your questions in. And if not, we can actually save some time and move to the next one. So, okay, I think we're going to move forward. And like I said, if you ask questions in the chat, we will also write the responses. And we can also maybe see if we have some time at the end in case we want to jump back on some questions. So yeah, for the next project, so make and light, they're gone to vector search library. Maybe someone can take over this one.
Yeah, I will also take over. So in the last project, we would be in the last project I just talked about, we would be working on this, on the core algorithmic part of ANLite or any NLite or any other vector search library to expand the capabilities, the algorithmic capabilities. But here we have a challenge is that this library is something that works locally, but it's not, it doesn't work in as a server where you have scalability and robustness. Okay. And we want to aim, so we have a feature that we are working on Jina that would allow to scale up stateful services by adding robustness by using some external libraries. And we want to evaluate if we can make sure that ANLite or any other of these vector search can be scaled using this feature and to what extent this happens. So to speak, we want the ANLite to be the brain of these algorithms, and we want Jina to be the orchestrator of this complex, these are the orchestrator of many replicas and distribution of this data for you. So the aim is that you as a developer, you have your own local solution building with your favorite vector search, hopefully NLite, but anyone would be valid. And with Jina, we can make sure that your throughput and your scalability is improved in a seamless way, so to speak.
Awesome.
So let me give a little bit of background of the challenge. So scaling a stateful microservice is challenging, but as scaling something that doesn't keep a state even in either in memory or in disk, it's quite easy using Jina or Jina plus Kubernetes. That is what Kubernetes is meant to be, and this is what Jina is really good at. But why is it challenge? Because when you scale, actually what you do is to add replicas of your service so that the client talks to any of the replicas in a seamless manner, and they can handle different, you can handle more workload at the same time. But if you have a stateful service that stores data, it's not so easy to make sure that there is an agreement between all the replicas of the data that they have present. And in Jina, we are working to add a feature that uses an implementation of a Raft consensus algorithm. For those not familiar, I think I have a slide explaining a little bit more, but it's a widely adopted algorithm that deals with this consensus problem where three or a cluster of replicas agree on the state that they have to share. And this would make Jina suitable for scaling these kind of services. And among other things, it could be used to scale local vector indexes. So as I said, you are working with ANN Lite or FICE or HNSWLib locally, and you want to scale seamlessly without starting a complex database, having to deal with the infrastructure and so on. Why would you want to do this? So one of the biggest advantages is to have better throughput, more queries per second, and so on, because if you have only a single instance of your service, you would be limited on the amount of requests you can handle. So the Raft algorithm, just so that we can understand, is make sure that a set of nodes agree on the state of a finite state machine when some input commands have been applied. It is a popular solution for many databases. I don't know, HashiCorp Console, a lot of databases use this algorithm to make sure that the replication and the distribution of data is in sync. And the question is, what is a finite state machine? So here is anything that deterministically changes its state given the same input command. And the hypothesis that we do here is that we can treat executors as this. We can make them fulfill this requirement. And then, so we assume that executors, when given the same input, the same document arrays, each internal state changes in a deterministical way. So the thing is, we are gonna make, using this algorithm, that Jina makes sure that your executors are in sync in a single cluster, in one Raft cluster. And then next slide. So what is expected is to build an executor using ANN Lite or any other local vector library under the hood and make sure that it can be used by this new feature that we add. And the main issue is to test and prove it works and assess the scalability and the scale of data that can be handled in such solutions. Then, since it's quite a new feature, we would expect that bugs and improvements would be needed. So it would be expected that whoever takes this project can contribute back to the framework. And then, if possible, try to deploy in Kubernetes using our infrastructure and build a nice demo about it.
Cool. That sounds exciting. So maybe then if people have some questions on this one, again, the same, please drop them in the Q&A function or in the chat. Now is your time. So there's a question, what specifically is the state? Is the set of documents or embeddings that would need to be indexed by the vector search feature added to the executor?
So the state would be, in this case, the internal state of the vector search. So for instance, if you take ANN Lite, every time that you add a document to this ANN Lite, there's an underlying graph. In Python, there would be represented by an object. So the internal state of this object, so to speak. But this is an abstract thing. It could be the amount, make sure that the set of documents that you have in memory is the same. With this abstraction, you can abstract to any more complex data structure that you could imagine.
Awesome. I think that was our only question so far. And Alan says, thank you. Yeah, so we have we have another question here. And then we have around 20 minutes to finalize our presentations. So also asked, I wanted to know about the project idea X, your own idea. I had asked about it in the GitHub issues and wanted to know more about this because I believe with the rise of services and technologies like ChatGPT, being AI and more, my project can also be beneficial. I have also listed out the other benefits that can be helpful to the Jina AI community too, based on my current understandings of AI services. So I think this is actually a suggestion for a project. So is it something we've seen on our repository as a suggestion? Because I think we already laid out the projects that we are. Okay, I think what we need to do is check it in the GitHub issues and then respond accordingly, because then we know more details about what it is that we're discussing. And then maybe we can answer there for you. So we had also another question from Ellen as well regarding hybrid search. Instead of combining scores, do we actually layer the semantic search on top of the vector search vector-based search? Sorry. So Anlight would try to service text that BM25 then matches on. Or did you get that one, John? Shall I repeat it?
Sure. Can you repeat it, please?
Of course. So question on hybrid search. Instead of combining scores, do we actually layer the semantic search on top of the vector-based search? So Anlight would try to surface text that BM25 then matches on.
Then this could be, so this would be part of the previous investigation. So if that's the best approach to the problem, that could be. So this would involve a little bit of literature review or something or stuff to see what is the best approach proven.
Great. And then just I think. Sorry, I just see that Alan asked something. He said that Sami already answered. So maybe we can. I'll double check this one, but maybe we don't have to repeat answer unless it's something. Unless we need to check it like specifically for this project, but. Maybe we move on to the next projects and I'll just take a look into this one. So I think we're kind of wrapping up. Maybe we can jump then on Jack support in DocArray version 2.
Yes. So I am the mentor for this one, and we during DocArray v2 we want to have a support for JAX. And if we go to the next slide, I will be able to explain what is meant in general. Maybe let me give you a brief description of DocArray v2 especially. So we work with different modalities and we give some layer of abstraction for pre-processing modalities, for compute on different modalities and to store different modalities. And in the different project, we look at the storage part with Anlight, and for this JAX one, we look at this compute part. Can you go to the next slide? So what is JAX? JAX is a deep learning framework. It's basically something equivalent in terms of functionality as PyTorch or TensorFlow. It's backed by Google. It has this kind of functional programming oriented. It's kind of the new kids in the block, the new deep learning framework. It has a NumPy like API. Yes, this is what is JAX about, and what is it? Yeah, you can go to the next one. What is expected is to add JAX as a computational backend to DocArray. What does that mean? Means that in DocArray we support several computation, like doing some search and embedding, or computing doing some operation and letting the user do some operation in DocArray, but backed by a compute backend. And right now, as of today, we have PyTorch support, NumPy support, and TensorFlow support, and we want to add JAX. And basically, we need to have added as a computational backend, which is an abstract concept inside the DocArray code base. It's not only about this abstract class, but we have as well tensor class, which is like the object that the user will directly interact with. It's basically just a wrapper of JAX tensor into and fuse it with like our concept of tensor, so that we have all of the common functionality from DocArray in the JAX tensor. That's the main idea. This will be an example how you will interact with this JAX tensor. It will be a class inside this DocArray.typing library. So what is expected? Mainly the last thing which is expected after implementing those two classes, a lot of tests, and make sure that everything is working and it's easy to use and it makes sense with the JAX philosophy and DocArray philosophy. To sum up, but I think I was brief enough not to have to sum up my slide.
Awesome. Thanks, Sammy. That was very quick fire. So if anyone has maybe some questions on this one. Avi can also ask, what are the types of functions we are expected to implement in JAX?
So, for example, there is this search function, which is basically computing the exact nearest neighbor and selecting the top k, like the 5th nearest neighbor. And this is, this kind of array operations that expecting to be implemented in JAX.
Okay. Then I think that's all the questions for this one.
Okay, cool.
Cool. So DocArray and libraries.
Yes, and this is another one which we want to add in DocArray, and the idea is, as of today, DocArray has several concepts, and one of them is this document index or document store, as it was named in the past. And those basically are like kind of ORM for vector database or for vector library. Right now we support several vector database and one vector library, which is HNSW. And you can go to the next slide. And basically we would like to add new libraries to be used inside DocArray, namely, this is potential library. So we are open to any suggestion on libraries, but this is some like the 3 ones that we think about, especially Face, which is super famous, Annoy or Pain and Descent. But this is the idea to add those as backend for DocArray.
Great. We did have a quick question on the JAX project quickly. So is it necessary to make the JAX integration computational speed less than Ethers currently?
Currently it's not implemented, so we cannot make it faster than, slower than it is right now. But in general, we have it's important to make the code fast, in a sense that it should be well written and not having some obvious slow problem because of the code.
Awesome. We asked basically where we're posting it. So on our official Jina AI YouTube channel, I will try to link it in a moment. Unless Shah, you're in the chat and can link our YouTube channel, would be super helpful. And so also another question, on going through the DocArray version 2 roadmap, you mentioned flattening and storing them on the database. How is it then indexed, particularly the line which refers to data to index? Also, I suppose document store should have different options of storing it on different vector backends. 2 parts. Mhm. So maybe Sami.
Sorry, I was muted.
Oh, sorry. I wasn't sure if I was muted. I was checking.
No, it's
So
fine.
you got the question, right?
I was
Okay.
saying yes. So how is it indexed? Particularly, how is it indexed? Well, basically, let's say we have a vector database which take the document array, and we take the document by batch, and we first that has been embedded using a machine learning model, and we have an embedding for each of them, and then we index. It means that we do a call either to a vector database or to the library to store it. And I suppose document, okay, yeah, it's rinser, good.
Yeah, sorry. I was also just muted. So just closing some questions that we've answered. I think I just want to make sure we didn't move any. Are we planning to use databases as backend like Redis and any other MongoDB?
Redis is in our plan. Redis, we used to have it in DocArray 1, so we definitely will add back it in DocArray 2. So I'm not sure it's really part of this epics, in the sense that we want more contribution on the libraries part, but we can think about Redis. For the other one, like MongoDB, it will definitely not be a document index, in the sense that it will not perform approximate nearest search well, unless MongoDB add this feature one day. But it's only like this document index is focused on approximate nearest neighbor. So if you're a vector database or a library, you can do it, then it makes sense. Otherwise, it's another concept that we have in the library, and it's not part of this project.
Great. And Ashut has also answered, so thanks for the answer. Also went through the rewrite branch and could only see support for HNSW library. Currently, when it comes to indexing on vector backend, you guys also mentioned Quadrant, Weaviate, and Elasticsearch, but I don't see its implementations. Do we have to write those implementations as part of the project as well?
No, we didn't see it right now. Actually, it's all of them are in progress, and we have open pull requests for all of them, and we are working on it already. So we no need to work on those ones.
Well, that's great. Great news. Okay, I think that's all of them. If anyone has more, is there any possibilities if we use the same backend with HSNW library or implement phase or annoy, need to create new backend and abstract doc index? I'm
not really sure to understand the question, but yeah, each time you add a new library, you need to create a new concept, like a class which will wrap all of the functionality. Of course, we have abstract class, and we have we try to factorize as much as we can between all of the backend, but you will need to add something new on top of everything.
Awesome. I hope this answers your question, Karen. If not, please rephrase. Okay. So I think we have 5 minutes left in case there is, okay, looks like that was the right answer. General question, is a PR merge to the DocArray repo mandatory or an added advantage to the proposal? Not mandatory. Okay, there we go. Quick one. All right. I think then if we don't have more questions, we're running a tight ship here. I don't want to make sure we respect people's times in case they're running to other classes or meetings. But I guess just to quickly recap, maybe we can answer in the chat, or let's see if we have a minute left. Just want to make sure you guys are aware of some of the deadlines and some information. So the application period is between the 20th of March and the 4th of April. The proposal review period is 4th of April to the 26th of April, and May 4th is going to be when we announce. So yeah, all of this stuff we will share. It's also a lot of information on our repository. And yeah, we'll definitely endeavor to share as much kind of details and information for you guys as possible that, you know, will help you to plan your time. Yeah, and so then I think what I want to make sure you're aware is, like, of course, please join our Slack if you haven't already, especially if you're taking part of the projects, because there we have also a support channel for this program, and you can ask also our team questions about it. Yeah, I just want to make sure you're aware of it. So when you do join our Slack, make sure you do look for that channel as well. And I just check chat and make sure. So thank you, Sha, for linking all these things. And I think that's everything. So yeah, huge thank you to all the mentors for taking the time to kind of go through all the projects, answer all the questions. Super excited and appreciate all the folks who are actually interested in contributing. This is something we are really excited about as well, and really, yeah, so grateful that you actually even have this interest to take part. And we look forward to the next steps. So yeah, awesome. Then enjoy the rest of your day or night, wherever you are in the world.
Bye-bye.
Bye.
Bye-bye.